Hello everyone, welcome to Site Programming channel. Myself, this is Hemant, belongs to Department of IT, First BTech. In this video, I am happy to discuss about selection sorting. Before going to know about selection sorting, you have to know clear about bubble sorting. And we have already done a video regarding bubble sorting, and that respective link is provided in the description. Please go and watch. Now let us come back to our concept selection sorting. It is a simple sorting algorithm. This sorting algorithm is as in place comparison based algorithm in which the list is divided into two parts, where the sorted part is at the left end and unsorted part is at the right end. Now let us take an example. In array ARR, the elements in that array are 19, 10, 8, 7, 9. Now these elements in this array are unsorted. Now after the sorted, the elements in that array are 7, 8, 9, 10, 19. Now let us see how we are going to sort the elements. In the iteration 0, that means in the first iteration, the memory allocation of the elements in that array are in the index 0, 1, 2, 3, 4. The elements are 19, 10, 8, 7, 9 are stored respectively. For selection sorting, I have to select an element in any index and I have to compare that element with elements in other indexes. While comparing this element with other indexes, it reaches its position. Now let us see how it is going to reach its position. For that, I am initializing I with 0 and initializing j with I plus 1. So for this I have to check the condition whether the element in I index is greater than the element in j index or not. So here I is at 0 index and j is at 1 index. That means I have to compare the elements in 0 index and 1 index. In 0 index the element is 19 and in 1 index the element is 10. Here 19 is greater than 10. That means it is satisfying the condition. So while it's satisfying the condition, I have to swap the elements in 0 index and 1 index. After swapping, here it looks like in 0 index the element is 10 and in 1 index the element is 19. Now I am going to increment j by 1. Make sure that I am not at all incrementing, I am not at all changing the position of the I till the iteration completes. So I remain at 0 index till the 0 iteration. Now I is at 0 index and j is at second index. Now again I have to check the condition whether the element in 0 index is greater than the element in second index or not. Here the element in 0 index is 10 and the element in second index is 8. Here 10 is greater than 8. That means it is satisfying the condition. Whenever the condition satisfies, I have to swap the elements in those indexes. After swapping, here it looks like. In 0 index the element is 8 and in second index the element is 10. Now again I am incrementing j by 1. Now j is at third index. Now again I have to check the condition whether the element in 0 index is greater than the element in third index or not. Here the element in 0 index is 8 and the element in third index is 7. Here 8 is greater than 7. That means it is satisfying the condition. Once the condition satisfies, I have to swap the elements. After swapping, here it looks like. In 0 index the element is 7 and in third index the element is 8. And again I incremented j by 1. Now j is at fourth index. Now I have to compare the elements in 0 index and fourth index. In 0 index the element is 7 and in fourth index the element is 9. Here 7 is not greater than 9. So here that means here the condition fails. When the condition fails, I am not at all going to change anything. I simply incrementing j. But here we can't increment j because j reaches the maximum position of the index. That means whenever j reaches the maximum position of the index, we can conclude that there the iteration is completed. So after the completion of the first iteration, the elements in the indexes 0, 1, 2, 3, 4 are 7, 19, 10, 8, 9 respectively. So here 7 reaches its position. How I am saying? Here 7 is the first smallest element among the elements in this array. That means 7 is the smallest element and it has to be at the first position. So it reaches its position. In the second iteration, these elements are going to be taken. In the iteration 1, that is in the second iteration, the values at the indexes 0, 1, 2, 3, 4 are 7, 19, 10, 8, 9 respectively. So as we discussed before, in the definition, the sorted part is at the left side and the unsorted part is at the right side. Here 7 is sorted, so it is at the left side. So remaining elements are at right side. So what is the difference between this iteration and previous iteration? In this iteration, I am going to increment I by 1. So that means after the completion of every iteration, I have to increment I by 1. But in those iterations, I have to increment j by 1 continuously. So in previously I is at 0 index, now I is at 1 index. And again I have to initialize j by I plus 1. So here j is at second index. Now again I have to check the same condition, whether the element in I index is greater than the element in j index or not. If the condition is true, I have to swap the elements in those particular indexes. Now let us compare the element in 1 index and the element in 2 index. In 1 index the element is 19 and in second index the element is 10. So here 19 is greater than 10. That means it is satisfying the condition. Whenever the condition satisfies, we have to swap those elements. After swapping, here it looks like. In one index the element is 10 and in second index the element is 19. Now I doesn't incremented I just simply incremented j by 1. Now j is a third index. Again I have to check the condition whether the element in one index is greater than the element in third index or not. Here in one index the element is 10 and here in third index the element is 8. Here 10 is greater than 8. That means it is satisfying the condition. That means I have to swap those two elements. After swapping, here it look like. In one index the element is 8 and in third index the element is 10. Again I incremented j by 1. Make sure that till the iteration completes, I am not at all incrementing I. So again I have to check the condition whether the element in 1 index is greater than the element in 4 index or not. So here 8 is greater than 9. It is a false condition. So I doesn't swap those elements. So again we can notice that the j reached the maximum position of the index. So that means the iteration completes. After the completion of the iteration, here 8 is sorted. That means 8 reached its position. So we can recognize that the 8 is the second smallest element among the all elements. So after the completion of iteration 1, the elements in indexes 0, 1, 2, 3, 4 are 7, 8, 19, 10, 9 respectively. Now we have to swap the remaining 3 elements. In iteration 2, that is in the third iteration, the elements in indexes 0, 1, 2, 3, 4 are 7, 8, 19, 10, 9 respectively. As I discussed before that after the completion of every iteration, I am going to increment I by 1. In previous iteration, I is at 1 index. Now I is at second index. Again, I am initializing j by I plus 1. So again, I have to check the same condition whether the element in I index is greater than the element in j index or not. If it is true, I have to swap those two elements. Now here, the element in second index is 19 and the element is third index is 10. Here, whenever we are checking the condition, that is here 19 is greater than 10, that means the condition is true. So when the condition is true, I have to swap the elements. After swapping, in second index the element is 10 and in third index the element is 19 and I am incrementing j by 1. So now j is at fourth index. Again I have to compare the elements in second index and fourth index. In second index the element is 10 and in fourth index the element is 9. Here 10 is greater than 9. That means it is satisfying the condition. Whenever the condition satisfies, I have to swap the elements in those particular indexes. That is here second index and fourth index. After swapping, here it looks like. In second index the element is 9 and in fourth index the element is 10. So here we can notice that j reached the maximum position of the indexes. So that means the iteration completes. After the completion of the third iteration, that means iteration 2, we can notice that 9 is the third smallest element among the elements present in it. So again we can notice that from the definition, the unsorted part is at the right side and the sorted part is at the left side. That means here 7, 8, 9 are at left side. The unsorted part 19 and 10 are at right side. So we have to sort the remaining 2 elements in next iteration. In iteration 3, that is in the 4th iteration, the elements in indexes 0, 1, 2, 3, 4 are 7, 8, 9, 19, 10 respectively. So we can remember that after the completion of the every iteration, I am incrementing I by 1. That means in the previous iteration I is at second index. Now I am incrementing I by 1. That means now I is at third index. Again I am initializing j by I plus 1. Now again I am checking the same condition whether the element in I index is greater than the element in j index or not. Whenever the condition is true, I am going to swap the elements in I index and j index. Now we have to check the elements in third index and fourth index. In third index the element is 19. In fourth index the element is 10. Here 19 is greater than 10. That means it is satisfying the condition. Whenever the condition satisfies, I have to swap. After swapping, here it look like. In third index the element is 10 and in fourth index the element is 19. So we can notice that the j reached maximum position of the index. That means the iteration is completed and all the elements got sorted. Here 7, 8, 9, 10, 19. That means in ascending order. So after sorting the elements are 7, 8, 9, 10, 19. So let us see the algorithm for this. In algorithm, we are going to start from step 1. In step 2, I am reading array of size 20, comma size. In step 3, I am reading the elements in that array. In step 4, I am initializing I with 0. In step 5, I am checking the condition whether I is less than size minus 1 or not. If it is true, I have to move to step 6, where in step 6 I am initializing j by I plus 1. And I will move to step 7, where I am going to check the condition whether j is less than size or not. If the condition is true, I have to move to step 8, where in step 8 I am checking the condition where the element in I index is greater than the element in j index or not. If the condition is true, I will move to step 9, where in step 9 I am going to swap the elements in I index and j index. If the condition in step 8 false, then I will move to step 10, where I am incrementing j by 1. And I will move back to the step 7 and again I am going to check the condition whether j is less than size until and unless the condition fails. Once the condition fails, I will move to step 11, where in step 11 I am going to increment I by 1. And again I will move back to the step 5. In step 5 I am again going to check the condition whether I is less than size minus 1 or not until and unless the condition fails. Once the condition fails, I will move to step 12 and I am going to print the elements in after sorting, and then I will stop. Here I will raise a question. So if the elements got sorted in first iteration, what I am going to do? Am I going to change any step in this algorithm, or am I going to change any condition in this algorithm? The answer is no. No, I am not at all going to change any condition or any step in this algorithm. Because once the element got sorted in any iteration, not only first iteration, in any iterations, so the condition in step 8 is going to be false in the next iterations continuously. That means here we sorted the elements in ascending order, that means small to big. So whenever we arrange it from small to big, the element in that index is must be smaller than the element in succeeding index. It might be greater than the element in with previous index, but it must not be greater than the element in succeeding index. So I am not at all going to change any step or any condition in this algorithm. So next we will see the program regarding this selection sorting. Have a look on it. Now let us execute this program. So this is the program regarding selection sorting. Now I am going to run it. It is asking enter size of the array. I am enter 5 and I am entering the element 6, 1, 7, 2, 5 and it is printed after the sorting elements are 1, 2, 5, 6, 7. So that means here it printed in ascending order. So it satisfies the conditions. So thanks for watching. If you have any doubts regarding any concepts, please let us know through by comment. Please like, share and subscribe for more videos. Thank you.